Hello guys, this is Akash and welcome to your fourth Spark tutorial. In this tutorial, we are going to explore what is key value pair computation, a simple word count program, and how to run Spark program in terminal. So let's get started. To do that, just trigger PySpark from the choice of your folder. So mine is on desktop. And that should do. So I'm going to create a new notebook. Okay, so let's change this to markdown format. Key value pair computation became popular with the release of MapReduce. MapReduce follows a paradigm of computation where a program has to be given a key and a value, and all the computation takes place by modifying the values and keeping key as some sort of centralized part of computation. So throughout the program, key will not be changed. However, the value will be modified in some sort of format, and eventually a batch processing will be performed. So let me give you an example what I mean by key will not be changed throughout entire program. So suppose that we are doing a simple word count program where we are given a word like hi, hello, welcome, Apache, Spark, welcome, Spark, and Apache. This is a simple document where you're given 3 to 4 different words, and we want to count how many times Apache occurred in this document, or how many times welcome occurred in this document, or so on and so forth. So to do that, as for the key value pair computation, this needs to be converted into a key value pair. How do we convert it? Well, we are just going to say that this is word hi and it occurred once over here. This is again hi, occurred once over here, and so on and so forth. And now what will happen is that eventually we will get what is known as a key value pair. Now the computation takes place by taking key as a centralized part. So what will happen is that we'll keep all the unique keys at itself, like Apache, hi, hello, welcome, Spark, right? And for all unique keys, we are going to combine the values that it has. So we are going to make a list. This is 1, 1, because Apache occurred twice and the value is 1, 1, so we combine the values. And same for hi, and then same for welcome and hello. Hello is just once, and Spark, sorry, this is 1, and Spark is 1, 1. Now what will happen is that we are, after combining this, all the values for unique keys, we are going to do some sort of computation on this thing again. We are going to modify the values where we are going to say that, you know what, just add up all the values that you get. So for example, Apache, sorry, I just misspelled it. Apache happened twice, hi occurred twice in the document, hello occurred once, welcome occurred twice, and Spark occurred twice. And eventually we'll get an answer that Apache occurred twice, hello twice, hello occurred once, and hi, and so on and so forth. So basically what you are doing is that in this case you summed up, but many times you could combine a table where you're given like a name of an employee, ID of an employee, and maybe address of an employee. And in other table you're given again ID of an employee, and then maybe gender of an employee, and maybe age of an employee. And by keeping ID as a key and rest of it as, you know, values, you could just do a joining operation on this thing where you'll be given name, comma address, comma ID, comma gender, comma age. And many different type of computation could be performed using this sort of computation paradigm, but you just have to think in terms of key and value pair whenever you want to do this sort of computation. Now remember, we talked about Hadoop and its limitation. This is one of the key limitations of Hadoop, because all the computation that you perform in Hadoop has to be represented in sort of key value pair computation, because it is the underlying paradigm of Hadoop and MapReduce itself, the algorithm that was released. So let's get started with a simple word count program in Spark. And to do that, just open up a editor of your choice. For me, it's going to be Sublime Text, and just type in just random words. So I'll have Apache, Spark, tutorial. And then welcome, hi, hello, enter. And then we are just gonna copy and paste all these things. Okay, so we have around 128,000 lines where each of the line contains one single word, and some of the lines are blank. So we are going to do some sort of data cleaning with this data. So let's save up this file as input.txt, and make sure that the file that you saved is in the same folder as your notebook exists. So I started mine on my desktop in tutorials folder where my notebook is, and at the same place I saved my input file. So make sure for you also it's the same thing. So now let's go back to our notebook and get started with the word count program. So to do that, first we'll need to load the file, and to load a file in Spark, all you need to do is just load it into RDD, where we'll say that sc.text file and file name, input.txt is our file name. And let me show you what our file contains. Oops, sorry. Yeah, print rdd.take 5, and this should give you first 5 words that are in the file. And you can see it's Apache, Spark, and Spark. And if you see, this also contains some of the blank spaces, the blank lines. Make sure that you don't have spaces in your blank lines. If you have, then you need to do some sort of filtering in similar way. So we don't want to be counting spaces as words when we get the total number of times Apache occurred in our document, and so on and so forth. So we want to count just the words, like how many times a particular word occurred in a document. So to do that, we'll need to filter out these empty lines. And filtering out command for the Spark is basically saying that rdd.filter, and we are going to use lambda functions to do that. Lambda x, which is an input, where x is not equal to this blank line, and you can see data.take 15 will remove those blank lines. And now all we need to do is just convert this thing into a key value pair computation. So to convert this thing into key and value pair, all we need to do is write another lambda function, lambda, yeah, there we go, lambda, where word is given as an input, and we return a tuple where we give out word comma 1 as an output, indicating that this word occurred once in this situation. And then all we need to do is write down another transformation on top of this, where we'll see that reduce by key. Well, before we do that, let's just data.take 15 so that you know what happens. So all you got over here is Apache comma 1, Apache comma 1, Apache comma 1, Spark comma 1, Spark comma 1. So eventually we converted this thing into a key value pair. And now we need to combine all these similar unique keys like Apache, all of them into one, and count the number of times that this once happened. and all you are going to get is some sort of like Apache and all other words with some sort of huge list of ones like this, and then Spark with some huge list of values like this, and all you need to do is sum up these values and you should get an answer. So to do that, reduce by key command is used in Spark. So reduce by key, all it does is that, okay, take key as a centralized part of computation, Apache, and just combine all the values, and then you tell that with all the combined values with this list of values, what do you want to do? In our situation, all we want to do is we just want to add them up. So given x comma y, you just return x plus y, and that's all we're going to do. So basically what happens in this situation is that Apache, here you can see it's 1 1 1 1 1 is going to first combine 1 comma 1 and it will get 2, and then it's going to combine 1, it will get 3 plus 1, it will get 4, and so on and so forth, and it will continue. And this is what we have specified over here. When you are getting the two values from the list, just add them up, and this should be a simple word count program in Spark which should give you an answer. So if we run it, let's run it, and you can see that Apache happened 25,000 times and Spark happened 25,000 times, and so on and so forth. Now, by the way, note that this tutorial and this tutorial are denoted as a different word. Well, because it is different word. This tutorial has a T with a T capital, whereas this tutorial has T which is of lowercase. Now, whenever you're doing some sort of program like this, you want to make sure that you either convert everything into a lowercase or you either convert everything into an uppercase, and you do some proper data filtering to avoid counting the same word as different word and counting them differently. So let's fix that. All we need to do that is just basically convert all the words into lowercase, and all we have to do is just say that whenever in our map phase, whenever you are given a word, just return word dot lower, so just lowercase word comma 1 as our key value pair and it should fix the issue. So let's run it, and now you see that all of them has been converted into lowercase and tutorial has counted just once, and hence the issue is fixed. And we have 6 unique words with each of them being this frequent in our input.txt. Now that we have written this Spark program, let's run it in terminal. So to do that, open up choice of your terminal, choice of your text editor. For me, it's Sublime Text, and all we gotta say is from PySpark import Spark context, and what else we need to import? Spark config, and then import sys, and that would be it. Now our input file is going to be sys.argv, the first argument that the system gets, and output file location is going to be the second argument that we give to our Spark program. And let's just copy paste this program over here, and we are going to change this to input. And now let's return, let's save this thing, data.save as text file output. Okay, now before we do that, what happens is that this is a parallel programming, and this RDD will be stored into many different partitions, and we want to get them all into a single partition. And to do that, we are just going to write coalesce command. We'll say that, okay, convert get all the RDD into convert all the data set into a single RDD, which has just a single partition. So let's just format our format our code, and our code is formatted, and let's save it as word count.py. Now, so let's go over this thing. Change it to inputs. Sorry, it's a keyword in Python, so rather not take it as a keyword. So we also forgot to instantiate the Spark context and configuration. Spark conf dot set app name as word count program, and sc spark context conf is equal to conf. Okay, so let's go over this simple word count program that we have written, which will run in terminal. All we are doing is importing Spark context and Spark configuration. So remember, in last video we talked that Jupyter Notebook will instantiate the Spark context and configuration for you. So that's why you do not need to instantiate new Spark context and configuration over here. However, when you are running your own Spark program, you need to instantiate Spark context. Now, why do we need to instantiate Spark context? Because we want our system to know that this is a Spark program and it needs to start up the Spark environment and trigger all the Spark services, and the Spark context would do that. Configuration, here we have just set our app name, and that should do. Here we are taking input. Now input is coming from the command line argument that we are going to give to our program, where we'll say that inputs will be the first command line argument that we'll pass to our program, and it will be taken as the location of the file, and output will be the output directory of our result, this data dot after doing this word count program. Okay, so let's run this thing into terminal. To do that, just open up terminal. Well, I already have it open, so let's open up a terminal and go to a folder where you have saved your notebook as well as input, and you can see that I have my notebook, input, and my program all in the same location. So make sure everything is in the same location to avoid giving the explicit path of your input.txt and everything. Just in case if your input file is not in the same location as your notebook is or your program is, you will need to give some explicit path over here. We'll say that user / whatever / input.txt. So here's where my file is located, and same is the case in this situation as well. Now, one of the interesting part about Spark is that if this input was located inside a directory, then all you can do is just specify that folder. Like suppose that, let's just make one directory called input, and move our input.txt into our input directory, and you can see that we have the input directory. So Spark provides flexibility to just provide directory as the input, and it's going to read all the files that are within the directory. Now there could be more than one input file in this given directory, cd input, and the reason being that you want to maintain some sort of parallelism level when you are running distributed programs. So you could have like hundreds of these files over here, and all Spark will do is then basically take one file as one partition of RDT, and then second file as second partition of RDT, which will be stored across different nodes. Now we are going to talk about distributed environment in the next tutorial, so don't worry about it as of now. Let's just play around with one single file over here and run it. So you can see that we have input as our directory, and all we have to do is say that Spark submit master which is our master node, by the way. This master, our master node is our local computers. Now you can specify one more argument like asterisk over here, which will say that use up all the cores that are available in my computer to do parallel programming, and it is going to use all of the available cores to do the computation. And then you provide your program name, which is wordcount.py, and then our directory name, which is input, and our output directory name, which is output. And all we got to do is press enter. And whoops, I knew it, there's going to be an error. And what is the error? Oh, okay. All we forgot to do was put a brackets over here and then save it. Oops. And then run it. And it's running. Okay, the program has finished running, and you can go to that directory to check on it, and you can see that output directory has been created and part 0.000 has been created, and you can see that all the output is located in this directory. Now you can prettify this output if you want to, but in this situation I do not want it to do that, so let's just limit our tutorial to this scope. I am running out of this time, so yep, I'm gonna see you in the next tutorial, and in next tutorial we are going to talk about how this program would behave in a distributed environment and some essentials of a distributed environment programming. So see you in the next tutorial, and if you have any questions, leave it in the comment, subscribe, and please give like to the video. Thanks.